Welcome back to this series on architectural simplification. Today we'll be looking at database migrations, specifically moving a database from one location to another. That could be on-prem to cloud, cloud to cloud, on-prem to on-prem, or cloud to on-prem. It doesn't really matter. A database is unlikely to live on one machine or one set of machines forever. It's likely that at some point you're going to have to move that database. And in today's demo, I'll be showing you exactly what that looks like prior to CockroachDB and with CockroachDB. In today's before scenario, I'll migrate a Postgres database from a source location to a target location. I'll start with no replication at all because I might not have realized that I would need to migrate my database at some point. So my demo today will involve me starting up a Postgres database. I'll assume that this will be the only Postgres database I will ever need. And then at some point I'll realize I need to migrate this database, and then I'll enable replication and perform the migration, which will look like this. Step one is my running Postgres database without the knowledge that I'll need to do a migration at some point. This is the point at which I realize I'll need to perform a migration. I'll need to migrate my database from a source location to a target location. I'll spin up an idle instance of Postgres, and then I'll begin replicating data to that instance. I'll allow replication to finish to that replica, and then I'll switch off the primary and promote the replica to be the new primary. In the CockroachDB example, I'll start a cluster, again, not in the knowledge that one day I might have to perform a migration. And then I'll bring up nodes in the target location, which will join to the existing cluster, and then I'll simply turn off the source cluster. I'll be running a long-lived application to simulate the effects of this migration on any consumers of the database, and that application will look like this. I'll connect to the database, and then after every second, I'll insert a row into the database, select it out again, and then print OK. That will allow us to check database connectivity during the migration process. First, I'll launch my primary Postgres instance. Note that I'm not making any attempts to perform replication at this point, simply because I don't know that I need to yet. I'll create my table. It's a purchase table that has an ID, basket ID, member ID, amount, and timestamp. Although for this example, that's irrelevant. I'll start my application running. And at this point, let's say we've been running for a while, everything's fine, but now we realize we need to move our database to a new location. First, I'll create a user that has the ability to replicate data. Next, I'll grant privileges to that user. And next comes the involved bit. I'll hop onto the primary instance itself, and then I need to make the database aware of a bunch of replication configurations. First, I'm going to open up the database entirely just to allow my replica instance to connect. This isn't advisable, but because I'm running locally, that's fine. Next, I'll set the write-ahead log level to replica and set a number of other configurations that are required for replication. Postgres will read these settings upon launch, so I'll need to restart it in order to take advantage of those new settings. We can see that there was a blip in the application, but that's expected because any in-flight requests would have failed at that point. And I found that the archive files that I'll need for replication don't actually get created on the first restart always. So I'm going to restart Postgres again. Again, this has caused a request to fail, but that's acceptable. Now I'll bring up the replica instance. I'll connect to its terminal, and then I'll start running PG base backup, pointing to the primary instance, connecting as the user that has permissions to the database. Next, I'll give the Postgres user access to the data directory. This is the directory where the primary database is being replicated to. Postgres itself doesn't know about this change until I restart it, so I'll update its configuration, and then I'll need to restart the replica. And now we can perform the cutover. I'll stop the primary. Essentially, we've started a downtime window. I'll log back onto the replica, and in order for it to serve requests, I'm going to need to promote it. And with my replica instance promoted to a primary instance, I can now repoint my application to that. And that's the migration complete. There are quite a few moving parts, steps, and human involvement required by this migration process. It's very complex, and my setup was about as simple as it gets. I was running a single node of Postgres for the primary and the replica. If I was using multiple nodes with different replication strategies or partitioning, that would suddenly become a lot more complicated. Let's move on to the after scenario now, where I'll perform a migration from one location to another, but this time with CockroachDB. First, I'll launch my 3 CockroachDB nodes. They're all going to be in a locality of US East 1 and join one another, so they'll all be aware of one another when they start up. I'll initialize the cluster. And then I'll run a very simple load balancer that I've created for this example, just to simulate the kind of load balancer you might have in front of CockroachDB anyway. I have 0 connections at the moment, and the servers correspond to the gRPC ports that I've exposed on each of those 3 nodes. I'll create an identical purchase table that I created for the Postgres example, and I'll run my application. Let's say now that we've realized that we need to migrate from US East 1 to US East 2. I'll spin up 3 new nodes in US East 2 and join them to the existing cluster. The locality flag reads US East 2, and it's going to join the existing cluster, in addition to the 3 new nodes that I'm going to add. Node 2 and node 3. Let's see what those new nodes look like in the cluster now. We can see that there are 2 regions now, US East 1 with 3 nodes, and our new region, US East 2, again with 3 nodes. There are under-replicated ranges because CockroachDB knows that it now needs to replicate data into the new region, and we'll see that as the replicas come over. US East 1 currently has 168, but the US East 2 region is catching up with 90 replicas. I'll let that settle down with 0 under-replicated ranges before I perform the next step. Our under-replicated ranges have gone to 0, and we can see that the replicas are more or less balanced across the cluster. My application is still happy with no interruption at all. With replication finished, I can now safely add the new nodes into the load balancer. These are the 3 new nodes in the load balancer, so all 6 nodes now can serve traffic. And because the new nodes can serve traffic and are available in the load balancer, I can now decommission the old nodes. At this point, we might see a failed request because any in-flight requests to the load balancer might bounce back and have to be retried. With the nodes gone, connections will only be made against the 3 new nodes, so I can now fully decommission the old nodes. And as we'll start to see, the nodes in US East 1 will now become decommissioned. And this node will now disappear from the live node list into the recently decommissioned nodes, which after a short while will be removed from the console. And that was our database migration in CockroachDB finished. We saw one blip as I took out the original nodes from the load balancer, but the database otherwise remained online throughout. We've just performed a zero-downtime migration with CockroachDB. The way that CockroachDB scales horizontally also has the side effect of allowing us to perform these kind of migrations. You start from one location and then you add nodes to the cluster in the place that you'd like to migrate to before removing the old nodes from the cluster once you're done. Contrast this to the previous example with Postgres and you've got a vastly simplified migration strategy.